Hi, welcome again to another chapter, another presentation in my debunking series of climate change due to the burning of carbon dioxide. In this segment, we will have a definitive look at radiation, infrared radiation. Again, this is another one of the very pesky subject that has a lot of false narrative associated with it. And so finally, we will be looking at this subject and dispelling all these myths and misinformation, false information, half truths, and innuendos about these subjects. So here are some of the false narrative associated with infrared radiation and climate change, and they are as follows. Infrared radiation is the major source of direct heating of the Earth's atmosphere. The greenhouse gas effect is due to secondary heating from long-wave infrared radiation. That long-wave infrared radiation is scattered by the carbon dioxide molecule in the atmosphere, which then produces secondary heating. That is this trap that this trapping of this secondary heat by the increased carbon dioxide in the Earth atmosphere by the burden of fossil fuel that is causing such a havoc on our climate. So, what is infrared radiation? Infrared radiation is part of the electromagnetic spectrum that mainly produces heat on its reaction with substances on the Earth's surface and in some cases in the Earth's atmosphere. Together with ultraviolet A radiation, they comprise collectively what is called thermal radiation. The electromagnetic spectrum is as follows. It's described as follows. Here you have the electromagnetic spectrum listing the most common types of radiation that comprise this spectrum. Starting from the most powerful, you have gamma radiation, then X-ray. Most people are quite familiar with these type of radiation. Then followed by ultraviolet, the visible spectrum or optical radiation, and the infrared, the one that we'll be spending a lot of time on today, infrared. Moving on to microwave, then further down the line you will have radio waves. However, as you can see, the thermal radiation comprises of the infrared and ultraviolet A radiation. Those are the ones that produce heat on the face of the Earth. Following that, we now have a breakdown of the various infrared radiation wavelength and types of infrared radiation, and the beginning and ending wavelength in nanometers. As you can see, as we go from near to very far wavelength, we see that the wavelength increases in size. For instance, short near infrared radiation has only 780, beginning at 780 nanometers and end at 1000 nanometers. So, in this slide, we'll be looking at the primary source of heat on Earth. The incoming infrared radiation of the sun is the primary method of heat production on Earth. It is produced primarily by the interaction with the matter on the surface of the Earth, the water and the land, the trees, the animals. Apart from the water, and water vapor in the atmosphere, the sun incoming infrared radiation has very little direct heating effect on oxygen, nitrogen, and carbon dioxide. It's important for you to note that the incoming solar radiation has very little direct heating effect on nitrogen, oxygen, and carbon dioxide, but it does have a huge effect, heating effect on the water vapor and the clouds in the atmosphere. Infrared radiation causes the animation of atoms and molecules in the matter and the production of heat. The longer they are exposed to and is energized by infrared radiation, the faster they are animated and the more heat that will be created. As the Earth matter becomes hotter, they eventually maintain an upper limit temperature by sharing some of this heat with atmospheric gas through conduction that is in intimate contact with them, or evaporate as is the case of water. So here we'll have a look on the properties of infrared radiation. First and foremost, like all radiation, it travels in waves and at the speed of light. Secondly, infrared radiation produces heat by causing the atom or molecules in a substance to vibrate. Infrared radiation is grouped into three classes, namely near or short wave infrared, middle wavelength infrared radiation, and finally far or long wave infrared radiation. Each is successively less powerful than the previous, respectively. Only near or short wave infrared radiation band from the sun reaches the surface of the Earth and interact with matter on Earth's surface to produce heat. This heating of substance on Earth by the short wave infrared radiation as a byproduct produces middle and long wave radiation that is emitted into the atmosphere and is called terrestrial infrared radiation. Each substance on Earth will react or be affected by very specific infrared radiation, and all others will pass through and pass by unaffected. Every substance above 0 degrees Kelvin or minus 273 degrees Celsius emits some particular infrared radiation. The hotter the substance, the lower the wavelength of the infrared radiation emitted. The following is a presentation of the wavelength of infrared radiation that affects or is affected by the carbon molecule. Here on this slide, we'll be looking at the infrared radiation characteristics in regards to its wavelength, its source, natural source in nature, the heat producing strength, its interaction with the atmosphere, how it interacts with the atmosphere, its interaction with the Earth's surface, the maximum temperature range for the strongest infrared emitters of that category, and finally the exposure intensity and duration to the atmosphere, exposure to the atmosphere. As you can see, for instance, in the near or short wavelength infrared radiation, the major source is from the sun, incoming solar radiation, and it's the most strongest heat producing infrared radiation. It is absorbed by water vapor and water droplet as cloud in the atmosphere. It interacts with all matter on Earth, producing heat. It is produced from objects of temperature of 3,540 degrees Celsius, which is very hot, which is about the temperature of the sun, and it is exposure to the atmosphere, very extensive, long, and intensive exposure during the day from the sun. In the most extreme of this, you'll find the long and far wavelength infrared radiation. And as you can see, the major source of this radiation is from regularly sun-heated object on the Earth's surface. It is the least heat-producing, and it is absorbed also by clouds and water vapor in the atmosphere. It is also absorbed by carbon dioxide in a very specific wavelength, one very specific wavelength out of a thousand of far long wavelength infrared radiation. We have only one specific radiation that affects the carbon dioxide molecule in the atmosphere, and we will look into this much further in this presentation. In regards to the interaction with the Earth's surface, it has little or no heating effect. Maximum temperature, the maximum temperature of an object that will emit this long wave infrared radiation is 89 degrees Celsius. That is hot, very hot comparatively. And in regards to the atmosphere, it has very extensive exposure, as all heated material emits this radiation naturally, albeit over a huge range of wavelength. Also, it must be noted that in the middle wavelength infrared radiation, there's also one band that is also very specific to carbon dioxide absorption, but this middle infrared radiation is very rarely produced on Earth, because it is produced from substance that have a very high temperature, and in this case you see the maximum temperature for strongest emittance comes from a temperature of 690 degrees Celsius, and that is why we say that when we have a volcano erupting, we will have very hot substances. These substances will give off this middle wavelength infrared radiation that only one band is affected by carbon dioxide. In this slide, we'll be looking at the various interaction and reactions of radiation, all type of radiation with matter. They are as follows. 1. Radiation can activate the electrons in matter, causing them to vibrate and produce heat, as in the case of infrared radiation and some ultraviolet radiation. Secondly, radiation can pass through matter without affecting it. This happens when the energy level of the radiation does not sync with the matter atomic or molecular structure that is impacted. As an example, the sun incoming infrared radiation has no effect on nitrogen, oxygen, and carbon dioxide in the atmosphere. Third, radiation can pass through matter because the wavelength of the radiation is too large, as in the case of radio wave, or too small, as in the case of X-ray, where enough of this radiation pass through matter with minimum interaction with electrons, nuclei, atoms, and molecules of the matter. Enough passing through to create a photographic image on a photographic plate. Radiation can break bonds in matter, forming new product or destroying the old ones, as in the case of certain wavelengths of ultraviolet radiation on living matter such as the skin. Radiation can be absorbed and be reflected, producing colors, illumination, as in the case of optical radiation. Radiation can be absorbed, powering biochemical reactions, as in the case of the optical radiation in the process of photosynthesis. Radiation can impact the nucleus of matter, causing a nuclear reaction, for example, a nuclear fission, as in the case of gamma radiation. Radiation can be powerful enough to pass through matter, causing molecular damage in the process, especially in the living tissue, as in the case of X-ray gamma radiation, producing cancers. Here in this slide, we will be investigating the infrared spectroscopy of carbon dioxide, and a spectroscopy is one in which shows what wavelength of infrared radiation that is actually absorbed by the carbon dioxide molecule. And from this diagram you can see that, as shown, carbon dioxide absorbs infrared in the following frequency, measured in micrometers. Carbon dioxide absorbs in only two very specific wavelengths, as we have mentioned earlier. Now we're taking a more in-depth look at these two very specific wavelengths, and the first one is 667 micrometer and centimeter, and this is equivalent to a wavelength of 14.922 nanometers, or 14.992 micrometers. And this wavelength falls in the far infrared band of the infrared spectrum, as you've seen at the beginning of the presentation. The second wavelength is 2349 centimeters. This is equivalent to the infrared radiation band of 4255 nanometers, and this falls into the middle infrared radiation band. So what is important now is to find out what's the temperature of an object on Earth that would emit these two specific bands of infrared radiation that will affect carbon dioxide. This is what we'll be looking at in the next slide. On this slide, we will now answer the question of what is the temperature, what is the Earth's surface temperature needed to produce the infrared radiation that will affect the carbon dioxide molecule. And from the diagram below, you'll see surface temperature, wavelength emitted, and type of radiation. And in the note you'll see how important is this radiation. This radiation given off by a very specific surface temperature. So in the first row you see a -70 degrees Celsius, and this is the wavelength that is emitted. This is the first wavelength that we see from the prior slide that affects carbon dioxide from the spectroscopy. It is important to note that the lowest recorded temperature on Earth is -89 degrees Celsius. That's the lowest recorded temperature on Earth, and the first wavelength that affects infrared wavelength that affect carbon dioxide is actually at -70 degrees Celsius. At the other end of the spectrum, we have the second wavelength that is absorbed by carbon dioxide is absorbed by object that is 409 degrees Celsius, That is the second wavelength that is absorbed. That is given out by this very hot object. And there's very few objects on Earth that actually reaches temperature, and that's why we say that this wavelength is only produced, for instance, when you have volcanic eruption that is several degrees higher than this actual 409 degrees Celsius, and will eventually cool down to produce that wavelength. It is important to know that the highest recorded temperature on Earth is actually 57 degrees Celsius. So these are sun-heated temperature. These are temperatures that have been reached on the Earth's surface by natural sun heating, 57 degrees. So in the grand scheme of things, um, there, all other wavelengths of infrared radiation does not affect carbon dioxide. So this shows that carbon dioxide does not produce any greenhouse effect in the atmosphere as touted by the climate alarmists. In this slide, we will be investigating infrared radiation interaction with atmospheric matter, namely carbon dioxide, oxygen, nitrogen, water vapor, and water as in clouds. As you can see, we'll be looking at how each band of radiation, namely short, medium, and long wave radiation, interact with all these various constituents. In the case of, for instance, near or incoming shortwave infrared radiation, as we have seen earlier in previous slides, in regards to carbon dioxide, there's no wavelength interaction. Oxygen the same, nitrogen the same, but with water vapor there's multiple wavelength interaction, meaning that the infrared radiation is absorbed and produce heat. As in also in the case of water vapor, water as in cloud, fine droplets of water. Uh, this form of water absorb all incoming radiation, infrared radiation. In regards to middle wavelength, there's only one. In regards to carbon dioxide, there's only one wavelength that interact with carbon dioxide. One out of a possible thousands of wavelengths, only one interact with carbon dioxide. In regards to oxygen, there's no interaction, and in regards to nitrogen, there's no interaction. In regards to water vapor and clouds in the sky, these are readily absorbed also by infrared, by water vapor and cloud. Looking at the far or long wave infrared, we see also again that carbon dioxide is only absorbed by one wavelength in this spectrum, one out of a possible thousand. Very specific indeed. For oxygen and nitrogen, there's no interaction. For water vapor and water in the form of cloud readily absorbs this long wave infrared radiation. So as you can see from this diagram, the takeaway from the diagram is that carbon dioxide is only absorb infrared radiation in two very specific wavelengths, one in the middle wavelength spectrum and the other one in the far wavelength spectrum. Very specific indeed, and we will look at that in later presentation. Okay, so on this slide, we'll be looking at how infrared radiation interact with some common Earth surface material. And as you can see, we have various spectrum, a wide spectrum of earth material from uh, leaves, plant leaves, bare rocks and soil. You have ice, snow, glass, building, animal, roads, and metal, water, sea, lakes, and clouds. And in regards to near, medium, and far um, infrared radiation, we as we go across, we see how they interact with these various materials. Near, 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 and short, infrared radiation. As you go across by water, it's absorbed, mostly absorbed, some reflective. In regards to plants, mostly reflective, some absorbed. Bare rocks, most absorbed, some reflective. Ice, reflected and absorbed. Glass, near incoming sun radiation is transmitted. In regards to building, it's mostly absorbed. Animal, mostly absorbed, some reflect. In regards to road surfaces, mostly absorbed. In regards to metal, mostly absorbed. So whenever infrared radiation is absorbed, it is heat producing. It produces heat. So when it's reflected, when it's mostly reflected, it is not. It doesn't. The more infrared radiation is reflected, the less heat is produced in the material that is impacted. So, so as you can see, water is mostly absorbed and some reflected. In regards to far radiation, let's have a look at that. In regards to water and water, it is absorbed. In regards to plant leaf, it is emitted. In regards to bare rocks, emits. These all emits. In regards to glass, absorbed and reflected. In regards to building, absorb. In regards to animal, emits. In regards to road, emits. So far long wave radiation generally is emitted by most material on Earth and absorbed by some. So, in summation and conclusion, we can draw the following conclusions. One is that the atmosphere is secondarily heated mainly by its interaction with the sun-heated Earth's surface matter, causing a cooling effect on such matter as it moves over and away from these surfaces. Two, apart from water in the atmosphere, infrared radiation passes through the atmosphere unaffected and unabsorbed. Three, infrared radiation is not scattered or reflected by nitrogen, oxygen, nor carbon dioxide in the atmosphere, and only on a limited basis by the water in the atmosphere. Infrared radiation either pass through or get absorbed when they do, they produce heat in the atmosphere. Apart from two very specific wavelengths, infrared radiation has little or no interaction with the carbon dioxide molecule in the atmosphere. These two very specific wavelengths of infrared radiation very rarely emanates from the surface of the Earth, and therefore is very insignificant in any secondary climate heating of the atmosphere. All the above therefore debunks all false narrative of climate change due to the secondary heating of the atmosphere by outgoing terrestrial long-wave infrared radiation that is trapped or scattered by carbon dioxide in the atmosphere. So, as you can see back from this presentation, we have debunked all the narratives concerning infrared radiation, and this should finally put to rest this insidious false information that has been allowed to permeate our society for so many years. Um, I this information is easily verifiable, and I will stand and challenge anybody who want to tell me that this information is not scientific sound and it's not scientific factual. So thank you for your time, for your patience, and see you in my next presentation.